Ja, ochtendtijd. Good morning. I like to explain a little bit about quantum mechanics, quantum mechanical phenomenon. And in quantum mechanics there are two phenomena known, and basically they are actually the same, one and the same thing. And one is the entanglement, so that if you have one particle and it splits apart, then the two particles are still linked together. They are entangled. And if suppose this happens here, and I take this particle and I bring it a third particle with it, with some properties, and I connect that with this one of the pair particles, then the features of the third particle is transferred to the whole system, to the whole two pairs, a pair of entangled particles. And that may seem strange, but if you look at it from a mathematical perspective, what happens is the mathematical properties, they spread out over the whole system. These two particles are not separated. They're one system, one mathematical describable system. And from a mathematical point of view, that makes sense. If you put a third particle in that system, the whole system changes, which makes sense as well. Well, this property is what we exactly see at, for example, this two-slit experiment. What you see is you have a particle cannon, and that emits a particle, let's say an electron or a photon, whatever. From that moment on, it behaves like a wave. You can describe it mathematically as a wave. Now, it passes through the two slits and put on the screen a wave-like pattern, which we know all for quite some time now. And but if you do that with individual particles, what you see is that the same wavy pattern appears, but then build up on single particles. But the thing is, so a particle behaves like a wave in going from the particle cannon to the screen in between the two slits, and then it behaves like a wave, a spread out wave. So the wave function, the wavelength is apparently big. But when it hits the screen, it becomes a particle again, visible as a particle, as a point dot on the screen. And but what happens in that process, if that wave function touches the screen, the detector screen, what basically actually happening is that particle or that wave function is it's not collapsing. The term is known as collapsing, but it's not collapsing. It is altering, just as in entanglement. The wave function adapts to the wave function of the screen, so to say. I mean, this is a massive object compared to the tiny electron that hits the screen. So it forces the wave function of the electron to alter to the wave function of the detector screen. So basically what happens is also entanglement. It gets entangled to the screen, and the screen has the detector screen has a way much smaller wave function, so that what happens is the electron that hits it, it goes from a big wave function with a big large wave length to comparable to a particle with a very small wavelength comparable with the wavelength of the detector screen. And in that sense it gets entangled. The properties, the wave function properties of the screen are laid upon or are transforming the wave function of the electron, since it's much smaller. And that is what I try to put across, that basically entanglement and transferring properties is exactly the same thing as a wave function collapse. And basically I don't like the word collapse, because nothing collapses. It changes, it alters. a wave function alters from one wave function to another wave function by contacting, in this case, the screen, and in the entangled pair example, also the wave function changes by contacting one of the, this is exploding, going out of each other, and a third particle is touching one of the pair particles, and thus the whole wave function of that whole system of the three particles get entangled, and the properties of the third particle is mixed with the properties of the entangled pair, even if they are so many miles apart. And that's what I want to put across, that basically the features that the processes with entanglement are exactly the same as what in the process what we call collapse, wave function collapse. Okay, this is the message. Thanks for watching. See you next time. Bye bye. Have a little time.